So in the last part we saw that we have started subtracting, but due to some reason the video got the recording got stopped. So let's continue from there only. So in the last video we saw that if we want to perform the subtraction of two numbers in BCD, then we have to first convert the given numbers in the BCD code, in the BCD representation. So first we have to represent the given decimal numbers in BCD. Then after that we have to write, both the numbers should be written in the BCD. Thereafter we have to perform the given operation. So as in this case, and we have to start from the LSD. So as in this case we can see that each digit is represented by its equivalent BCD. Then starting from the LSD, lowest significant digit, if I keep on subtracting the first group, if I perform the subtraction in the first group, then I get this as the answer. Okay. Then whether in this case the borrow is required from the next higher group or not, that is to be checked. If there is a borrow, then we have to subtract 6 from the answer. So that is what we have explained in the last video also. So in this case, let's start from the lowest significant digit. So as we can see, this group is smaller than the other group. So if we perform the subtraction, that is, if I subtract 1 minus, if I do 1 minus 0, so it will be 1. 1 minus 0 will be 1. 1 minus 0 again will be 1. But 0 minus 1. 0 minus 1, as 0 is smaller than 1, so it cannot subtract. So we have to borrow from the next higher. Now, as the borrow is, as we have taken the borrow, so the condition which we have studied earlier, that if we borrow from the next higher group, then is subtracted from the difference term. So this is the difference term. Okay. So you see, this is the difference term. So this is the difference term for the first group. Now as 1 is borrowed, so we have to subtract 6 from the difference. So this is the difference, and from that we have to subtract 6 more. So the 6 more has to be subtracted, and if we subtract this, so 1 minus 0 is again 1, 1 minus 1 is 0, 1 minus 1 is 0, and 1 minus 0 is 1. So this is finally this we get. Now you check this, whether this is a legal code or not, legal BCD code or not. If this is a legal BCD code, then we will write it the equivalent decimal number. If it is not, then we will again have to do, because we need to skip the illegal codes, illegal terms. So then again we have to add 6 to it, okay, or subtract 6 from it. So we have to move to the next state. So okay, accordingly. So you see, now again we will see that this, by performing this subtraction from this number, again as there is a borrow, we need to, because this number is smaller than this one, so again we need to borrow from the next higher group, which as in this group all are zeros, so we need to borrow from this group as well. So the borrow will come first to this group and then to this group. So both the groups will require borrow, so the 6 has to be subtracted from both the groups. Okay. In this case, the illegal codes, the possibility of the illegal codes will not be there, because the illegal codes will only come when it is above 10. But because you are subtracting, so the illegal codes should not come here in this case, but there will be borrow. So if there is a borrow, then we have to subtract 6 from it. Okay. So subtracting this, again, now this each of the code is an legal code, then we represent it with its binary, with its decimal equivalent. So we can verify it, that now again the answer we get is same as the subtraction which we have done in the decimal number. Now these two answers are same, and if you want to show the answer in BCD, then the correct answer is this, not this one. So we need to be very much clear that what is our correct BCD the answer of the BCD subtraction of these two numbers. So this is this, which is 5898 decimal equivalent. Moving on to the next operation. So up till now we have seen the arithmetic operation of in BCD. So arithmetic operations, we have seen how to perform addition in BCD codes and also the subtraction of two numbers in BCD codes. Now let us see that if we want to perform the addition, perform the, let's say again we have to perform the subtraction in BCD code, but now by using some complement method. So let us say the complement method is 9's complement. Then you can do it for the 10's complement also. So let me try it for 9's complement. The rules will be same. The rules, whatever we have seen earlier, the rules will be same. But here we have to do it in the 9's complement. So to perform the subtraction in 9's complement, the only thing which we need to consider extra is that we need to represent the other number which need to be subtracted into this 9's complement. So how to do that? So let us say if I perform the subtraction of these two numbers in decimal number without using any complement method, then the subtraction answer should be this. Okay, 136.7. Now I won't explain this everything in detail. You know it. This is this. Now if I want to use the 9's complement to perform the subtraction, then we will take the 9's complement of this 1 minus 168.8. So 9's complement of this number will be 831.1. Okay, you have to subtract all the digits from 9. So 9's complement of this number is this 831.1. Now if we add up these two numbers, then our answer is this. Now we have to see whether the carry is generated or not. In case of 9's complement method, if the carry is generated, then we call it that round around the carry. So we add this the carry to the last bit. So adding this up, we get 136.7. So this need to be added to the decimal point. Okay. So this carry is generated, so it is added here. So after adding it, we get the correct answer is 136.7. Now this is the answer. This is the normal subtraction answer. This is the subtraction answer of using the 9's complement in the decimal number system. Now we want to perform the same subtraction in BCD. So how to do that? Again, the method will be same, the procedure will be same, but the only difference is we have to take the 9's complement of this number, and then that is we have to write the binary, this BCD equivalent for the 9's complement of the number. So that is what we have to do. So we have represented these two numbers in this way. This is the same number, same as it is. Now this is the 9's complement of this number. So we have noted that number same again here. Now we will represent these two numbers in BCD. So representing these two numbers in BCD will be 3, this, 0, this, 5 is this, 8. Okay, you can verify it from your previous table. There is no change. So just to save the time, I am showing you this. Then this is the 9's complement of the previous one. Now after representing this, we have to see, we have to now perform the addition. So whatever operation is written, we have to do that. So 1 plus 1 is 0. Okay, so 0 I have written. 1 is carry forward. So 1 plus 0. Okay, both are zeros. So it will be 1. So then no carry. So 1 plus 0 is again 1. No carry. So this is okay. So we didn't require any, this no carry is coming forward from this step. So as no carry is generated, we'll write it as it is. Again, we will see the same thing, because we are performing addition here, although we have to perform the subtraction, but to perform this using the 9's complement or the 1's complement method, we have to do the addition. So if we are doing addition, then we have to follow the rules of addition. So if we are doing addition and the code is an illegal code, then to skip the code we have to add it with 6. Although here in this case there is no such situation, so we don't have to do that. In the next step, again we do the same thing. We see that there is no carry forward of the bit from this group to this group. So as there is no carry forward, then we note down the same answer, the same bit at this place. Next, for the higher group, checking it again, no carry forward from the previous group. So again it is written as it is. Now moving on to this group, the MSB group. So in the MSB group we can see that if we perform the addition, then the addition will have some this illegal code. So 1011 is not a legal code in BCD. If this is the case, then as I have told you, we have to add 6 to it. So we have added 6. So BCD of 6, not 6 directly, but the BCD of 6. So I have added them up. So after adding them up, we see that a carry is generated. So now in 9's complement method, we know that if a carry is generated, we have to AND around the carry. So this is what we have done earlier as well. So if we do the AND around carry, we can see that if we have to add it here. So that is why this 1 is coming here. Now after again performing this final step, what we do is adding it here. We see that this will become all ones. Then this will be your 0110, then 0011. Now if we write the decimal equivalent of this, each of the group, then we can see that it is 136.7. Now this is same as the previous one. So we have not only performed the subtraction in BCD, but we have also verified that what the result should be. After verification, we find that the answer is same as the earlier. So this is how we have to perform the subtraction of two numbers in BCD using the 9's complement method. Similarly, following the rules of 10's complement, you can try the 10's complement, perform the subtraction of two BCD numbers in 10's complement. You try it by your own, and if you have any doubt, you ask me in the tutorial class or in any doubt clearing class. Okay. So moving on to the next number system, next coding scheme. So next coding scheme is our axis-3 coding scheme. In the earlier slides, we saw that our axis-3 code is also a sequential code. So as a sequential code, in the sequential code, the next code is one bit higher than the previous code. So as it is, there is a difference of 1 in the two codes. So this particular type of codes are used for mathematical operations. So axis-3 code is also used for mathematical operations. So we will see the mathematical operations of various numbers in axis-3 also, because this is a useful code to perform the mathematical operations. So now first of all, we will understand that what is an axis-3 code, how to represent it, and then its mathematical operations. Then how to perform mathematical operations in axis-3 code. If the two numbers are given in axis-3, then how to perform the addition, subtraction, and subtraction using 9's complement or the 10's complement. So let us see that. So axis-3 means excess, means extra. Okay, so 3 means extra by 3. But the 3 extra in what? In binary or in the BCD? The answer is it is BCD. So what we have to do is, if suppose I want to represent any number in axis-3 code, so first I have to represent the number in BCD. Then to that I will add 3 more. So it is BCD plus 3. So if you do BCD plus 3 more, then it becomes axis-3. So axis-3 over BCD. Okay, it is not binary. People usually make mistake and they do binary plus 3. So if they have to, up to 0 to 9, the two will be same. But after 10, if you do, let's say after 9, if you do the, if you write the binary equivalent of 10, then it will be 1010. And if you will add 3 to it, it will be sort of 12, 10 plus 3, so 13. So 13 is not a correct code. Okay, so this will be wrong. But if you want to represent 13 in axis-3, so axis-3 mein, in axis-3, what you have to do is you have to represent the BCD of each digit, decimal digit, or if suppose you want to represent 10 in axis-3 code. So you have to represent 1 in BCD, 0 in BCD, and then to each of the groups separately you have to add 3. If you add 3 extra to the BCD of each digit, then it will become axis-3 code. This is the correct way to represent a number in axis-3. So let us first write the the basic symbols from 0 to 9, how to represent the decimal digits from 0 to 9 in axis 3. So that let us see first that. So the axis 3 equivalent of decimal digit 0 will be how much? It is BCD plus 3. So BCD is 0 0 0 0, and if we add 3 to it, it will be 0 0 0 0 plus 0 0 1 1. So the answer will be 1 1. So 3 more is added. Similarly, if we see similarly you can write the axis 3 code for the numbers from 0 to 9. So the code will not start from 0, the axis 3 code doesn't start from 0, but it starts from 3. So the first code will be 3, then you see 4. So 0 is 0 0 1 1, I should read it like this. 1 is 0 1 0 0, 2 is 0 1 0 1, 3 is 0 1 1 0, and so on and so forth. You can see that up to 9 the codes are up to 9 the code is the code word, the axis 3 code for 9 is 1100. Moving on, let's try to understand the same thing with the help of an example. So in the example, let us try to convert the decimal number 96 in BCD and axis 3 code. So if I want to represent this 96 in BCD, so how I will do it? So 9 in BCD, I will represent 9 in BCD and 6 in BCD separately. Then I will rewrite them together. So 9 in BCD is 1001 and 6 in BCD is 0110. So BCD will become 1001 0110. Now if I want to represent the same number in axis 3, then I will add 3 to each of this BCD. So 1001 plus 3, so this is actually 9, 1001 plus 3, so it will become 1100 because you will add 0011. So 0011, so 1 plus 1 is 0, then a carry will become, so 1110, then this is how you will add, so you will find that it will be 1100. Similarly, if you add 3 to this also, this is 6, if you will add 3 to it, it will be 9. So now the number 96 in BCD should be written like this, and 96 in axis 3 will be written like this. So this is what the difference between BCD and axis 3. Axis 3 is nothing but BCD plus 3. Again note it down, it is BCD plus 3, not binary plus 3. Don't make this mistake, that you first write the binary equivalent of that any number and then add 3 to it. This will be wrong. Okay. Moving on to the arithmetic operations in axis 3 code. Again, there are some rules for this. So let us see this, and this is again to skip this illegal states, or you can say that we'll understand the rules by the example, taking out the example, doing the example. But again, the important thing is we have to start from the lowest significant digit, which I have not written here, but you remember this, that whenever we have to perform any arithmetic operation, it is like correct to start from the LSD, lowest significant digit, not from we shouldn't start from the MSD, most significant digit. Okay, so starting from the lowest significant digit, what we will do, what we want is, you have to perform this addition. Okay, perform the following addition in axis 3. Now the point to note down before performing this addition is, see, whenever you perform addition, there are only two possibilities. The first possibility is there is no carry is generated. Okay, if no carry is generated from a group to the next group, so then in that case we have to subtract 3. Okay, so we have to subtract it. And what is the reason to subtract 3? Because if you will add two numbers, see, this number is 3 more because it is axis 3, so BCD plus 3, and this number is also 3 more. So you want the number in axis 3. So if you will add two numbers, both the numbers are excess of 3, so they are excess by 3. So the total answer will be excess by 6. And if you want the answer in 3, then you have to subtract 3. So if you will subtract 3, you will get the answer in excess 3. Otherwise, the answer, if you add two numbers in which extra 3 is added to each of them, so the answer will be added by extra 6. But you want the answer, in answer you want the word, the each bit to be 3-bit extra. Okay, I mean 3 should be added to it. So it should be 3 more, not 6 more. So if you add 3 to each of them, so the answer will be 6 more than the correct answer. But you want 3 more than the correct answer. So in excess 3, what we do is, as no carry is generated, so we subtract the 3 from it, because this is the reason. If there is a carry, okay, if carry out is there, okay, because if you perform addition and if the carry out is there, then if carry out is there, add 3 to it. Okay, again the reason is 3 is the same, that if you add two numbers, then there are two possibilities. After performing the addition again, as I have told you, carry will not mean no carry forward, or the carry forward is there. Again, if you do the carry forward, then there are two possibilities. The code which you get after performing the addition is a legal code or an illegal code. If it is a legal code or it is an illegal code, you have to do the same thing. So because, and this what you have to do, you have to add 3 to it, okay, to skip the illegal code, to skip the illegal terms. This is what the answer is. And this is done because when the carry, when there is a carry, the invalid states are skipped. So that is what I was telling you, that the to get the correct legal code, we have to add 3 to it. Okay, you can understand it easily by the help of an example. So let us see, if we perform the addition of these two numbers, okay, perform the following addition in excess 3 code. So let's say the two numbers are 247.6 plus 359.4, and I want to, this is not this number, this decimal number is not in excess 3, this is a decimal number. So if I perform the addition, then the answer should be 607.0, right? Now if I perform the addition in 6-bit in excess 3 code, then also I should get the answer same, 607.0. But now 6 will not be 6, but it will be 9, because it is excess 3. Then 0 will not be 0, but it will be 3, and 7 will not be 7, but it should be 10. So we will see that how to do that. Okay, excess 3. So 10 means 7 in excess 3 will be written by 1010. This 0 will be written by 0011, and 6 will be written by 0110, and 0 will be written by 0011, same. Okay, so the answer should contain such a term. Okay, so we'll see how to do it. Let us see how to do it. So start with, so first we'll represent each of this number in excess 3. So representing each of them, each of the numbers, so you see 2 in excess 3 will become 0101, 4 0111, 7 1010, 6 is 1001. Same for the other group. Okay, I am skipping this. If you find any mistake in the calculation, you just point me out later. Okay, you bring that in my notice, I will correct it later on. But I think it is correct and we can skip it safely. So now after performing this whatever operation is given, so we have to perform addition. So if I perform this addition, so 1 plus 1 is 0, again same. Now carry is generated. If carry is generated, then you see there are two options. So no carry, so subtract. Carry out is generated from the group, so then we have to add 3 to it. So you see, as the carry is generated in the next group, so we will do what? We will write this as it is, and now a 3 is added to it. So because a carry is generated from this group, so we'll add 3 to it, right? Same thing is here. Now we will perform, after doing this, a carry is generated from here, so this and this carry will come to the next group, so this carry is coming here. Now as this group is also generating a carry to the next group, we will add 3 to this group. Okay, so you see we have noted down, first we have performed this addition, we have noted this down, then after this we have added 3 to it, 3 more to it. Okay, so this is our this thing. Now after doing this step has generated a carry. So again performing this addition, the answer is this, and 1 is added to this. So again that has generated a carry forward to the next group. Now after performing this, we have noted down this 4 bits. Again this, as this has generated a carry, so we'll add 3 to it. So adding 3, we get this is the answer, right? These are certain rules which you have to remember. If you can't remember, then you can understand simply with the help of an example. I have already explained you that how to do it. If you still have doubt, you ask the thing in the doubt class. I'll clarify it, or in the tutorial class. Now from the next step, the final MSD state. So we see that if we do it, then again this is our carry forward is generated to the next state, next group. If I perform the addition again, the answer is 1100. Now in this particular thing, no code is this is generated. Okay, no, what is this? 1011. So this is our this particular thing. Okay, so check the rule. So no carry out is generated, so no carry out is generated from this group. So if we perform the addition, so no carry out is generated. If no carry out is generated from this particular group, then we have to subtract 3 from it. So this is why we have subtracted 3 from it. From the other groups, the carry were generated, so we have added 3 to them. So this is what the reason, that is very clarified, very clearly written here in this step, in the here also. So you can accordingly you can do the this operation. So doing this, we find that no carry is generated here, so 3 subtracted, and performing this subtraction. So you see 0 minus 1 not possible, so you have to borrow, although the borrow will be from the same group, but you have to borrow. Okay, so borrow, so 10 minus 1, so again 1, then this will be 1, so 1 minus 1 is 0. Now this is, you have borrowed from here, so 0 minus 0 is 0. Now this is remaining, so 1 minus 0 is 1. Now this is a legal term, 1001. So this 1001 is the axis 3 representation of actually 6, because this is, if you write if you see the binary equivalent of this, or the BCD equivalent, the decimal equivalent, so it will be 9. So this is 3 more, so 3 more of 6. So you see this is 6. Okay, now this is 3. So 3 in axis 3 represents 0. This is 10. So 10 actually represents 7. So this is actually 7. So I should say this is 607. Point. This is what? 00. Okay. So 001. Okay. Sorry. This one is, by mistake I have not written it. So sometimes this happens. This small type of this, what I should say, this typing mistakes occur. So please ignore them. Or if you have doubt, you still, for this also, if you have any doubt, you talk to me in the tutorial class. I'll correct that. Okay. So sometimes this happens. So you see, this is again one is left out here. So one I should write here. So this will be 0011. So this is again your 0. So the correct answer is 607.0. Okay. So one is like missed here. Okay. So please note it down. So this is 1 here. Okay. From this step. So you have to add them up. So this is how you have to perform the addition in axis 3 code. Now let us see the subtraction. How to perform the subtraction in axis 3. Again, the rules are same. I can explain them in short. I'll explain them in short, and then we will do it with the help of an example. And if still you have doubt, you can ask me in the doubt class. So start from the LSD again, and here in this case, if no borrow is there from the next step, so add 6. Okay, add 3 to the difference term, because the result is in binary. If there is a borrow, subtract. So if you are borrowing, then you have to subtract. If no borrow is there, then you have to add 3 to it. Okay, see now what will happen. Again, the reason is same. The reason was same as we have discussed in the last slide. So 57.6 minus 27.8. So if I perform this subtraction, 57.6 minus 27.8, so normally, I mean in the decimal number system it will be 29.8. Okay, 6 minus 8, you can do it is very easily, it is 29.8. Now to perform the subtraction in excess 3, again I have to write the numbers, each of this decimal in binary, sorry, BCD. So I will represent each of them in BCD. So this is represented, this is excess 3 for 57, then this is the excess 3 code equivalent for 27.8. Now we have to subtract, so I will perform the subtraction of this from this. So 1 minus 1 is 0. Now 0 minus 1 is not possible, so borrow. So 1, 0 minus 1, so 1. This is 1, so 1 minus 0 is 1. Now this is, see, this is number is previously I have borrowed from here, so this was 0, so I have to borrow from the next group as well. So if I am borrowing from the next group, so you see, if you borrow from the next group, then subtract 6 or subtract 3 from the difference term. So we have to subtract 3 from the difference term. So this is our difference term, we will subtract 3 from it. Okay, the reason is again not difficult, it is simple, because you see, this is 3 extra, this is also 3 extra. Now you have subtracted 3 from 3, so this is the correct answer. But now as you want the answer in excess 3, okay, so you want the answer in excess 3, so you have to subtract 3 more from that to get the answer in excess 3, right? So this is what you are doing. So again you are subtracting this, so 0 minus 1 is not possible, so you will borrow from this next, so it will be 1 0 minus 1, so 1. Then again this is 0, so you borrow from 1 0, 1 0 minus 1 is 1, this is 0, so you have borrowed from here already, so 0 minus 0 is 0, this 1 is 0, so 1 minus 0 is 1. Okay, so this is how you do it. So this answer will be C. Now this is your answer in excess 3. Again same things you are doing. If, see, here this is like, if you will do this particular operation, you will get, again after doing the borrow and all those things, you can see this is the answer. If you subtract this, then you will get this answer. So this is nothing but the excess 3 representation of 2. This is the excess 3 representation of 5. Sorry, it is 5. Then this is, there is probably some mistake, so let me check it. So let's check it. So you see, if we perform the subtraction, then here it is looking correct, because this is we have done already. But if we'll do this, because we have do this, it's not looking correct. 1 minus 1 is 0. Okay, 1 minus 1 is 0. So then, okay. So you perform, so you see there is some mistake here. So it should be, if we perform this subtraction, if you subtract this 0011 from this number 1111, then it should be 1100. Okay, not this. So this is particularly wrong. By mistake I have written. So this should be 1100. So please note this down, and then the correct answer will be 0101, so which is 2, then 1100, which is 9 in excess 3, and then 1011, which is 8 in excess 3. So this is the correct difference. Now moving on to the other thing, so other operation. So in the previous, while we have seen the while seeing this BCD subtraction, we have used 9's complement. Here we will use 10's complement to perform the subtraction in excess 3. So let's perform the following subtraction in excess 3 code using the 10's complement method. So how we will do that? Again, the method is very simple, not difficult, but the only thing which we have to be careful, and we have to follow the same rules. If in case of we know that if we perform the subtraction using 9's complement, then and around carry is there. But if in case of 10's complement, if there is a carry is generated, we ignore it. Okay, and if the answer is negative, then we take the 10's complement of the answer. So this is what the rule is. So we have to follow the same rule. So if you want to do the this subtraction in of this number using the tens complement method, then we have to take the tens complement of the lower this number, which has to be subtracted. So tens complement of 672 will take, and which is coming as 328. It is easy to take the tens complement. To take the tens complement, you have to subtract each of these numbers from 9, whereas the last digit is to be subtracted from 10. So if you do this, you will get the excess. Now this is the tens complement of the number. Now the excess 3 code of this number, okay, and you first have to represent this number in BCD. So if you represent this number in BCD, okay, so then excess 3 code of this 672 is this. Okay, excess 3 code of 672 is this. So excess 3 code of 9's complement of 672, which is 328, is actually the tens complement of 672. So you want not the 9's complement but the tens complement. So we have to write the 2's complement of this. Okay, so this is the number in excess 3 number of this, so you have to write the 2's complement of this number. So 2's complement of this number in excess 3 will be this. Okay, so we have first done what? We have done the excess 3 representation and then 2's complement and added 3 to it. Okay, so this is excess 3 code in 672. Okay, so this is the excess 3 code for 672. Okay, now we will add, we'll just have to reverse the bits because we want 2's complement of this number, the 672, which is the excess 3 code, okay, which is already the excess code. So you want just the 2's complement of this. So to get the 2's complement, we will perform this. So it is again performing the complement of each of them. So you see, so again same, but the last bit here will not be inverted. So we'll do this. Okay, so doing this 2's complement of this excess 3. Now we want excess 3 code of this, which number? The 354, the first number. So excess 3 code of 354 is this 354. Okay, so this will be 3 plus 3 again, 5 plus 3 and 4 plus 3. Now if we perform the subtraction in a usual way, so it will be 318. If we perform the subtraction using tens complement method, then we can see that there is no carries generated. So we have to take the tens complement of this and we have to put a minus sign in front of that. So the answer, as no carry is generated, we have to take the tens complement of this. So the tens complement of this is 9, then this is 3, 1 and 8. So 318, and the answer 318, and then we have to put a minus in front of that. So the answer will be minus 318, right? Now we will do the same thing using this tens complement and the excess 3 code. Okay, so to do the excess 3, first we write the excess 3 code of each of them. So 354, then the excess 3 code of the other number, which is this number. So we have to write the excess 3 code of 328, not 672. Okay, because we are using tens complement method. So 2's complement of 672 in excess 3. Is it? Okay, because it is 2's complement. So 2's complement of 672. Okay, we have written 672 in this one. So 2's complement of 672 in excess 3. Now we add them up, and adding them up will give us this thing. Okay, so this is how we do. So there we are doing tens complement of this number. So here we have to do the 2's complement of that number. Okay, so 2's complement of this number. So that is why I have written the 2's complement of 672. Now as we have to perform the addition, so we perform the addition in the usual way, and then we find that this is, see, 1 plus 1 is 0 again we will do, and we see whether the carry is generated or not. So we see that from this there is a carry is generated. Okay, so the next the carry is generated from this group to the next group, so we add them up. Okay, so this carries, that is why this one is coming. So this one is coming from this step. Okay, yes, right. Now again perform this addition, and after performing this addition we can see that this has not generated any carry to the next step. So no carry will move from this step to the next, this group to the next group. But then if we perform the addition, this addition of the previous carry generated to this group, then we find that this is 1110. Now again we see whether the carry is generated or not. If, as in this group, we can see that this group has generated a carry, so we will add 3 to it, okay, because it is in axis 3. So this is what we know, that if we perform the addition in axis 3, then no carry is generated, so 3 should be added. In this case we can see that no carry is generated, so this group doesn't generate any carry, so 3 will be subtracted from such a group. Here also no carry is generated, so again 3 subtracted from this group. Now after again performing this operation, we can see that the answer is 1001, 1011 and 010. Sorry, 0101. Okay, so this is our final answer for this, and we can see that this answer has not generated any carry. So because this we are doing in 2's complement, so this is our 2's complement, so 2's complement has not generated any carry. So if no carry is generated in 2's complement, we take the 2's complement of the answer again. So if we take the 2's complement of this, so it will be, see, this last bit will remain as it is, whereas other bits will all be replaced in all the other bits. The zeros will be replaced by 1 and the ones will be replaced by zeros, except this last bit. This is how if you do, so it will become the 2's complement of that number. Okay, so doing that, 0 1 1 0 starting from here, so 0 1 1 0, then 0 1 0 0, then 1 0, okay, you see 1 0, then 1 1. Okay, so you have inverted all the bits except this bit. So this is the axis 3 code of 318. Okay, so this is how you get it, and so as you have taken the complement, so the answer is minus. So there should be a minus in front of the answer. So this is how you do it. Now let us see what is called as, okay, because the video is getting a little longer and I don't have much space in my mobile, so I'll record this in the next part. So thank you for listening. I'll continue with the gray code in the next part. Thank you.